start. So, welcome everyone. How are you doing? So, I'm Dan from Red Hat. This is Kilton from EdgeWorks, and I hope we'll manage today to put some sense into the edge computing, the new buzzword lately, and see, what it's all about. Try to put into perspective where we are today with the various efforts, and put some perspective of where we could go next with the current IoT projects and the edge computing. So, in order to know where we are going, I think it's good to always start and try to figure out where we are today and how we got here. So we are living in the cloud computing era, right? Cloud native era. So everything is connected to some kind of a centralized cloud. So all the websites, all our browsers, mobile phone apps, even IoT devices in how we deploy them today, we usually do deployments to the central cloud, right? And I found this very useful when I was trying to dig up a little bit about how the shifts in the computing generally changes over the time, and you can see we are going from the centralized compute to the distributed compute, then and back and forth, right? So first we had the mainframes, one big computer where all the workloads were running in one single place. Then came PCs and the client server era, where we basically had fat clients and our databases and some of the logic hosted on the servers, some on the client side. So we had like a distributed computing era for the first time. Now we are in the cloud computing, as you said, and even we are all doing a lot of microservices and we are saying everything is distributed. But for the deployment model, it's all centralized. It's all running in a data center, and everything needs to connect to that data center. So that's why we see that the shift toward the edge computing will be again distributing our workloads all over the place. So outside of the core cloud. And I always like to say that our industry, it's a fashion industry, right? So what's popular, everybody start gonna do that. But with each one of these shifts, it's not for no reason, right? Every time we go from one shift to another, the scale of things increased a lot, right? So going from the mainframe to the client server to the cloud computing. We added more and more websites, more and more people on the internet, more and more devices to the IoT. So from the other aspects as well is if you want to go to the next scale in terms of how many things and data we're going to process, we need to go to the next shift, and that's edge computing, right? So one of our meetings and discussions we had, and trying to to paraphrase what edge is in a single sentence, and one of the colleagues, Steve from VMware, came with a edge is everything that's sitting outside of the core cloud. No matter no matter what it is, and we will come to some of the classifications in a minute. And again, why we want to do this? And the main idea is, is that we want to bring our compute resources, so our CPUs, our storage, and everything as close to the data sources as possible. And those data sources could be users, could be devices, could be anything. But we want to be able to bring our resources closer to the source of the information, and to actually actuators that needs to do something with the actual process of those data, right? There's a lot of triggers, and to actually have a shift in computing paradigm, you need to have like a perfect storm of multiple things happening at the same time. For me, the cloud native computing is the main trigger for edge basically, because it's the same thing like with the start of IoT. It's not the first time that people try to put some computing distributed everywhere, install some applications there, and you know, call that edge. What's different now is that we have all these tools that we built for cloud computing. So all the development processes, CI/CD pipelines, everything we need to do. So we don't want to put resources somewhere and forget about them. We want to extend our cloud beyond one geographical data center, one geographical location, and have it spread geographically all over the place, and be able to develop our applications in the same manner as we develop them for the cloud, just being able to have a flexibility where we deploy those workloads. Where they live in a one cloud, where they live in a hybrid cloud environment, will they be like a constrained nodes environment? It should be the same developer experience from the top down. And that's one trigger. Other triggers are IoT stuff and sensing becoming cheaper and cheaper, so more and more data becoming available. So we need new tools to handle that. It's physically impossible to have everything connected to the cloud because of the bandwidth restrictions and not being able to put all this data for processing to the central cloud, right? Yeah, this is what I already covered in the previous slide. So, and then when you start talking with people, what's edge, right? You get like a million different answers depending from where the people are coming from. So where people come, so I usually go from this side left, but as we are here like a IoT community, we can go from the right. So for us, like for a long time, we had IoT gateways and all those things. So we call those device edges. So small devices that are doing some kind of data processing and communicating with the clouds. But we can see that even in this area, the hardware is becoming cheaper and more powerful. So you can have a bigger boxes instead of the gateways, or even creating a small clusters, replacing those gateways, so you can do more and more in this last mile. But then you got a lot of provider guys already, so big telcos, ISPs, CDNs, and those people don't want to be dumb pipes anymore. So why would CDN only host your images and videos when they can provide infrastructure for deploying actually some kind of processing logic there, right? And getting the slice of the cake. They already have all this infrastructure, you know, point of presence all over the cities, all over the countries. So they initially want to do that and enable those sites to be proper clouds, right? And then we are coming into the traditional enterprise core and core data centers as we have them in the mainstream today, right? So what are some of the main things? Why would we would want to put these workloads closer to the sources? And a couple of things pops up immediately when you start talking with people. Latency is the first one. So we want to be able, for certain applications, to react locally as close as possible to basically reduce any latency between the data producing and acting on the data. So there are a couple of very good examples here. Like, you know, gaming industry is a good one, because milliseconds in some of the games are literally life and death change, right? But there are a lot of things where you don't have the luxury of putting all the data to the cloud, processing all the data and putting results back to the source. I was talking to Moritz this morning, and he says he has a machine that produces a camera that produces 1,000 of frames a second, yeah. And he said, like, he needs to react on that. So try to put that over the DSL to the cloud and process there. So they want to bring more compute to the machine itself to be able to process all this data there. Other thing is usually reliability and HA. So as soon as you start going geographically dispersed locations, network connectivity becomes unreliable and expensive. So some of the use cases for this are sites that we want to update occasionally and have the feedback from occasionally, but it's normal for those to have to be offline for long times. I think a good use case here is like big ships or cruisers or cargo ships which can be on the sea for weeks and then sync up back to the central cloud once they dock into some of the ports, get all the data out of that and get the updates back. But we want to manage those workloads in the same way as we manage all other workloads. We don't want to have a separate paradigm for all that. And the other one, this is the closest one to the IoT. We want to, this is what IoT gateways we're doing for a long time. Get some kind of data pre-processing locally, normalize data structures, deal with the variety of field protocols, and do some basic analytics there. Add some metadata to make sense of the data before you send them further, right? So we still want to do that. And there's one more thing that's popping up more and more lately, and that's data sensitivity. And basically, due to different laws, maybe some data is not allowed by law to leave a physical site, right? GDRP. I think I heard somewhere in China also that the GPS can't leave the country. So you need to have those data processed locally, maybe mask it in somehow and send it back, send it further to further analysis, right? So as with everything else, wherever there's a benefit, there's a cost, right? So I found these slides very beneficial for that. So the more centralized you go, you benefit for the better economies of scale. So you have one control plane for thousands of nodes, and it's very cheap in that sense. So the closer you get to the smaller sites, so it's the smaller data centers, the nodes and things like that, the cost of the control plane becoming more expensive, right? So the mantra that I like here is centralize when you can and distribute only when you must, because you will incur a lot of costs doing that. But in the other way, when you go to the edge, you get a better, you don't care about bandwidth, you get a better resiliency, data sovereignty, latency, all the things that we already mentioned. Typical, yeah. Sure.
Why do you centralize when you can distribute when you must? You could also argue that you should centralize when you must and distribute when you can.
Sorry, can you repeat?
If you switch can, you must. Mm-hmm. I would think there are also compelling reasons to do that, right? When you choose.
I think every distribution incurs cost in complexity, cost in price. So yeah, but that's where you must have resilience. If you don't must to have resilience, then go centralized. I think that's don't do it. Yeah. If you don't have to, yeah, that's exactly the point. Yeah. Yeah, but the more centralized, it's cheaper and it's easier. And everybody is doing cloud computing today. Nobody will say it's easy. So you can imagine doing cloud computing on the edge. It will be even I think order of magnitude more complex things to manage, as we as we know, right? So the key applications that we are seeing popping up, so large scale IoT, right? Smart infrastructure, as I said, gaming industry, like telco service has incentives to put the game servers as close to the users as possible. Everything that needs some kind of offloading of compute intensive tasks. And that can be done on devices, and it's too expensive to be done in the cloud. Some specialized nodes that will run close to the devices, like VR and ML things are good examples. Automotive, I would put that as well as in the smart infrastructure, because the car itself needs some kind of help, or I would assume would need some kind of help from the local infrastructure to do a processing. And of course, security and surveillance, that's the video, yeah. video, yeah. And it's a good comparison, like traditional IoT, like comparing temperature versus video. It's completely two different kind of payloads you need to handle, and again, two kind of different infrastructure you would need to do that properly, right? So there's a lot of challenges. So that's why we came. Like, why do you don't want to do distributed if you don't have to, right? So I like to separate them into broad categories. So one is the infrastructure. It's how we actually get our resources on the site, right? So somebody needs to go there, install things, and provision those clouds and servers, and you don't have IT personnel usually on those locations. So it needs to be managed by the operational guys, and it needs to be as simple as possible to do it. The other one are control plane challenges. So how do we actually get our workloads there? So, you know, what tools we use to actually, you know, do all these things and put them there and keep them updated regularly. And finally, once we have the workloads there, how do these things communicate back to the cloud and maybe you know, communicate between itself, and how they create a smart fabric of microservices that will actually do some meaningful thing, right? So we don't have too much time. It's a short session, but the basic challenges here are always getting into similar categories. So resources, you know, everybody likes cloud computing because it's infinite autoscale, right? In theory, you have a burst of your CPU, you press the button, you get a new node, and everything is fine now. Even if you have a cluster on the edge, it's not auto-scalable, right? You have, you know, a couple of nodes there, and somebody needs to go there and do something physically, which is expensive, and so it won't happen that often, right? As we mentioned network multiple times, so I wouldn't spend too much time there. Security, Kilton's topic, it's always like we don't running all these things in a data center anymore. So it's an unintended operation. Somebody can tamper with the hardware. How we protect against all that? So everything that's public infrastructure, it's a different security concern than the servers running in a secure data center. And from the point of developing the microservices, we have a lot of different concerns as well. So how we deploy them, you know, we need to make sure that we have enough resources for those services on the nodes where we want to run them. Again, communication over you know, crossing the realm of private and public networks, and again, security, because someone can tamper with the box, right? And make sure that we are running what we want to run. So I'll pass on to Kilton now. Sorry for taking too much time. Tell us where we are today with all this.
Yeah, so there's so much to be handled that, you know, there's nothing out there that handles it all yet. But let's take a look at the Eclipse IoFog project and some of the progress being made there. And we have a ton of resources. Oh, nice and grainy. We have a ton of resources around these subtopics too. So I'm going to dive into the internetworking at the edge, but security at the edge, we can provide links to papers and things. Just any one of those subsections could be an entire talk, and we just don't have time for that, unfortunately, today. So if you're not familiar with it, Eclipse IoFog is a project that is intended to fit alongside IoT frameworks and existing software layers that do actual application level things, sit on top of whatever infrastructure and hardware you want to use, and then foster the development of edge applications. So that might make you say, well, then what on earth is it? Because as far as I know, an IoT framework sitting on top of infrastructure should produce edge applications, but I'll highlight some of the things that need to be done to make that work. So on the very lowest level, something needs to turn a piece of edge hardware into something manageable. And so has anybody played with Raspberry Pi or Jetson Nano, things like that? Yeah, I see a lot of heads nodding. It's great when it's tethered to your laptop. You give it some instruction, then you flash it, and then you fire it up and you say, okay, cool, it's like unlocking my door, it's taking my temperature in the house. But what would you do if you had to command 1,000 of those units from your IT center, from your network operations center, and they were out in a factory somewhere? which each of them being, another 10 steps past the last. There's no way to handle that. It's not the same as your home tinkering. So if you put some software layer out on the hardware to abstract it, it becomes something that you can treat as if it were a cloud resource. And so the job of the Eclipse IoFog agent, which is what this is an illustration of, is to abstract that hardware and make it manageable, make it more easy to develop edge microservices that work against it, and so on, and also monitor its condition and all of that. Above that, you add the edge nodes together and you get something called an edge compute network, which is what we're going to dive into here today. And you also then have the emergence of a control plane that fits with what you normally use. Do we have it 100% right yet? No. In fact, we're just learning how many different environments are going to need to be handled, but you probably have infrastructure, maybe Kubernetes related, maybe not, that you would like to keep using. But then how does that begin to manage the edge? Well, something has to give you a control plane that's programmable, and IoFog also has those pieces. So a single edge node is managed by this piece of agent software, and then the control plane is what makes it possible to deal with all of those edge nodes together. And then what does this do to the development life cycle? You're accustomed to developing software that runs on machines that look very similar to the machine that you've been developing software on. So i.e. you build on your laptop, and then you containerize the application, and you push it out, and it goes on to x86 architecture machines with a good amount of RAM that are highly connected in a cloud environment or data center. When you're at the edge, you have 200 IoT gateways in a 4-kilometer long factory and assembly line environment. So from your laptop, how close can you get to that environment in order to see if the software you're building is going to work? They become very different. So you have to have something that makes it a little bit easier to build. And so it's all about providing developer tools that make the edge environment look local enough so that you can at least get close to understanding how this is going to be deployed on the IoT gateways or whatever edge hardware. And then giving you the ability then to do some local testing, see if it's actually going to work. Do these microservices work together? And then finally, enter this concept called EdgeOps, which is DevOps for the edge, in which what you built actually runs on the edge hardware easily. Because if the installation took, as you said, a bunch of IT people getting deployed out to that factory, spreading out and each of them handling 10 devices per hour, you're going to break your entire budget on just trying to deploy the stuff that you built. So something has to make it work on the edge nodes like it does in the cloud, and that's the EdgeOps concept. So I mentioned already this thing called an edge compute network. And this is a screenshot of the UI that lets you see an edge compute network, but what on earth is this? This is an application level network that rides on top of existing network technology. So not going to replace what normally connects things. If you're connected over LoRaWAN, if you're connected via TCP/IP on a LAN, or you're using cellular connectivity to get back to your cloud, all of those things are still viable. But what's going to make those all merge together? Some software network called an edge compute network. And so edge networking has some challenges that are really different than any of the challenges of the past. One of the main things is that we have the subnets that allow us to have LAN operations and still talk to the internet or to a WAN and so on. And to enable that, we have network address translation layers. We all love these because it allows us to have 30 devices in our home that can all reach the internet, but the internet cannot reach us. But if you have 5 warehouse locations, 2 factories, and a bunch of vehicles on the road, and you want to do logistics and shipping and supply chain application, you're going to have to overcome all of these NAT layers and be able to pass data laterally. That's a huge task, and usually it involves opening VPNs, which is a problem in itself, not only because of the cost of an operational workload of deploying it, but also because a VPN certificate in a vehicle is a huge security opening. Because if somebody gets to that vehicle and gets the compute hardware out of it, they basically have access to your data center, your warehouse, all of this stuff because the vehicle has been allowed access. Wouldn't it be better if there was a way to keep the net layers in place and still traverse it? So if we have application layer addressing, which is not the first time that we've done this, then you can keep all of the underlying networking intact and have some way of addressing the services that are needed, the software that needs to interconnect, and use that instead as the way of routing information. And this actually, it's not just a workaround. This isn't like just a way to overcome the network challenges. It actually adds a ton of value. So being able to interconnect services across all the different networks gets you where you need, and then you get some benefits from it that are amazing. How about access control for the addresses? Right now, we have this kind of problem, which is getting on the network is half the battle to getting access to the data. I want to talk to your Postgres database, and you don't want me to do that. Once I'm in your building and find a way on the LAN, I'm halfway there. But if you have an address, an application address system where the addresses and the access to the services across different networks are administered through a software layer, you have protections that are built into the system saying, are you really able to talk to the service? I'm not allowing it, so I'm not routing your data. Whereas a TCP/IP LAN just doesn't do that at all, right? You need hardware firewalls and things to try to keep you out. And in addition, you have limited exposure, and then you can develop this concept of whether an edge environment is trusted, untrusted, and you get better management around this. So there's some really great benefits to application layer stuff. So enter what's about to happen with Eclipse IoFog. Up until now, and I'm super excited about this. This is like the best project I have seen to handle this layer of networking. Up until now, Eclipse IoFog has had a, call it rudimentary edge compute network capability. It'll move your information from site to site through NAT layers, but boy, what happens when one of those sites is not available temporarily, and it was the routing hop, you know? So Project Scupper is a new Red Hat project, and you can check it out, of course, at Scupper.io. The idea here is to move traffic, whatever it needs to be, not just data messages, right, but pure network traffic, move it using AMQP 1.0 protocol in a way that allows you this management over its movement and does all of the NAT traversal and the firewall traversal that we've been talking about. It's an incredible project, and we're about to integrate it into Eclipse IoFog so that you can optionally use this as your way of doing all of your edge internetworking. My guess is that people are going to far and away choose this method once they see how powerful it is. So that's something cool to check out, and that's how we're going to overcome some of these challenges. And so let's talk about the way forward for edge computing, especially with regard to open source. And back to Dave.
Yeah, thanks. And it goes right nice onto your. So, but before we go there, so the first question is cloud dead, right? Everything must be dead at some point to make a hype believable, right? So of course it's not, right? So we have a lot of IoT projects going on today. In the cloud base, so Hono, Ditto, and even in non-IoT scenarios, the cloud is still valid, right? So the cloud is still the central aggregation of all your meaningful data, storage of long-term analytics and logic that doesn't belong on the edge. So it's not edge computing is going to kill cloud computing. It's an extension of cloud computing to do specialized tasks at an appropriate place. So there's still a lot of benefits of the work we did for the cloud IoT platforms within the Eclipse IoT community. But some of the things we can do better in the future, and we already tried to do something like that last evening at the. No, it was a great experience. So take a look at the current Eclipse Hono architecture and the architecture that is built for the cloud native computing from the ground up. So everything is microservices. We have a couple of different services there. So protocol adapters dealing with protocol translations and onboarding devices into the cloud. We have a messaging network application network that we mentioned before, and then behind that we have a business services, right? So if with the Scupper project we have this application messaging network distributed all over the different, you can call them like, this can be a whole cluster, this can be one node in one cluster, it doesn't matter, right? It's a service running somewhere on some compute node, but they're logically interconnected in this way. So if we have this, we can also distribute the Hono architecture as well. So protocol adapters can live closer to the devices itself, do the protocol translation. We can have some of the services living there, consuming data directly at the sites for different reasons, right? And then, you know, publishing maybe some other more valuable data, less noise, more data, back to the cloud. And the other thing is that you know, the Hono itself is always a means to an end, right? The messaging and networking and connectivity is never a complete solution. So if you take this business service and say it's a Ditto, digital twin service. So, you know, once we have distributed Hono, we can basically maybe try to distribute the things API. So why the whole state needs to live only on the central location in the cloud? Maybe we can have a replica of data or subset of data where it actually belongs, where devices actually live, right? So there's a lot of things we can do with the current IoT cloud protocols and try to distribute them in a way that fit this new edge computing paradigm. And there's a different kind of also applications that could be done. So we had traditional IoT gateways based on Java and OSGI for a long time. We can maybe rethink how we do that. We can do them in a cloud native way with more resources, more caching, more computing, more analytics, more machine learning on the site, doing all the best practices for CI/CD to push the services there and to actually manage those applications. Questions? Sure. Okay. Yeah. Yeah. For me, like, edge computing should be like you're developing your services in the same way wherever they run, right? And then you, yeah, and you only have a flexibility where you want to physically deploy them. It should, and I think the most benefit would have the application that can be, you know, centralized in the cloud or maybe distributed depending on the use case, depending on the particular use case. Yeah.
The containerization model is kind of a first, you know, easiest thing to do for packaging, virtualizing software, and moving it out. But going forward, there'll be additional models. Unikernels are good, serverless functions at the edge, and yeah, as you said, Dan, it's about how you build it and move it out. But it might be VMs are the best solution, and that's what you want to be running on the gateways. But somehow you need to be able to put them into your build pipeline and develop for them as easily. So yeah.
Thanks. Yeah, that's pretty much all we had. So if there's more questions. Yeah.
So one of the worst things that could have ever happened was the emergence of the term fog computing, because the concept makes a lot of sense, right? A low cloud is fog. You might not care where the service is running in your local environment, so should it really be called an edge, or is it something softer, right? Something a little bit more nebulous. In reality, fog computing and edge computing are always addressing the same concepts. But if you want to draw a line, Fog computing tends to refer to more of an abstracted environment where you may end up running a service on a box that's down the hall in another room because you don't care. And edge computing usually refers more to a location that you really care about, such as I would like to take the video and put it to the processing box that's right here in this room because it's involving what's happening in this room. But the two overlap so strongly that they're often interchangeable. In fact, I was so sure that the term fog computing would win as the default term that the project Eclipse IoFog used to be called IoFabric, but we had trademark conflict and we needed another name. I was so sure that fog computing would win that we changed it to IoFog. I wish now that we had called it IoEdge. But so, you know, it may undergo a name change, right, for that reason, but in truth, the two are used synonymously and probably will be for some time. Yeah. Any other questions? Yes. Mm-hmm.
And even I think in Eclipse community we have IoFog and Fog
Mm-hmm.
maybe you could make some clarification where you complete each other, where competition.
Yes. So rewind to 2005 and the emergence of some of the first cloud platform technologies. The same problems will be solved multiple different ways. So there is overlap. There is overlap between the functionality of KubeEdge and IoFog and FogOS, which is how you technically say FogO5, the delete speak. So now everybody's handling a different area as well. So what you get from KubeEdge is an MQTT-focused local deploy for gathering data and issuing commands that merges with Kubernetes. You can do that with IoFog, but you do need to choose to deploy the MQTT broker and things because it's not built into the architecture. KubeEdge is Kubernetes only. IoFog works with Kubernetes, but that's optional. FogOS is very focused on the telecommunications and multi-access edge cloud and MEC stuff, but it also has a lot of the same functionality. So what you use for each scenario probably should depend on what it was built for and what it is you're trying to accomplish. In the end, many of these projects will begin to work together, integrate together, possibly even merge, because we're trying to solve edge computing with a lot of different workers around the globe, and overlap should be expected. But also, marketing confusion is rampant in the edge computing space, as it was in the early days of big data, as it was in the early days of cloud. So if you have clarification needs, just ask any of the folks at the Eclipse Foundation, and or ask me, ask Dan, and we keep abreast of what's happening in the industry. Happy to give some answers, but it is a very confusing time. Yeah, that's it.
Thank you. So we'll be around. So if you want to talk more, feel free to approach, and yeah, we can talk about this for days, right? Thank you for coming.